This video is brought to you by Sportland, quality, integrity, and tradition.
So the customer's complaining that these they call them low boy drawers, 2, 4, 6, 8 drawer unit is not working. Now, I open this up and back in here, there's a temperature controller and there's a defrost clock and it was stuck in defrost. But I doubt that's the only problem. So let's go up onto the roof and see what's going on. You can clearly see the drawers don't shut either. They're just beat down. Well, this is the compressor in this rack and it is flooding back bad. The discharge is like lukewarm. We are flooding back because all the coils just turned on. That defrost clock might have been part of the problem. And sight glass looks to be flashing too. So what I'm going to do is go get some service gauges, put them on this guy, probably throttle down that suction valve and try to reduce the liquid refrigerant coming back to this compressor right now. All those TXVs are wide open because the box is at like 50 something degrees right now. That's a mess. The defrost clock downstairs should not be in play. For whatever reason, these units have 2 defrost clocks. They have one up here and one down there. The one up here has the right time on it, and I prefer them to be up here because they're easier to be accessible. So the one down there, I typically don't put any defrost in it, and then just use this one, because then you can control the defrost a lot better. So, all right. Well, let's get some gauges. All right, I'm going with probes on this one, so I'm probing up on it. But before I actuate this suction service valve, it's not a king valve, it's a suction service valve. I know it's semantics, but a king valve, the only place that a king valve is installed on a refrigeration system is on the outlet of the receiver. That is the king valve, okay? The inlet of the receiver would be the queen valve, and every other valve on the system is basically going to be a service valve, okay? So suction service valve, discharge service valve, okay? King valve on the outlet of the receiver, queen valve on the inlet of the receiver. All right, but anyways, the suction service valve has a packing nut, okay? Right here on the bottom, that is a packing. There's a flat surface to put a wrench onto it. I actuated it. You want to loosen the packing nut. Now, keep in mind when you loosen a packing nut, you might actually get a little bit of a refrigerant leak from the packing itself, okay? But by loosening the packing nut, you're extending the life of that service valve when you have to actuate it, okay? This is a standard 3-way valve, so now, okay, so we're getting a little bit of a leak right there. That wasn't the leak that I was talking about. That was just because my probe wasn't tight enough. But we actuated it now, so now we're getting system pressure saying 56 psi. I'm going to go ahead and get the high side on, and then we'll be able to evaluate it more. The flooding seems to have subsided significantly. Discharge line's getting warmer again. Compressor's not vibrating and shaking anymore. But we still look to be flashing in the sight glass. So on the king valve itself, you can actually get a better idea of a packing. You can see right there that it has a flat surface for an adjustable wrench to connect to. So then we're just going to loosen that before we actually actuate the valve, okay? There you go. So now the packing is loosened, and then we can go ahead and put our service probe on there, and then we can actuate the valve stem on that valve, okay? That there. I've already zeroed out my probe to make sure that it wasn't under a weird pressure or anything, okay? Now, I said that sometimes these will leak. If you're worried about it, you can throw the cap back on. It'll kind of subside the leak down. Keep that in mind too when you're doing evacuations on these systems. Those packings always leak. They're never 100% leak free, so you gotta make sure you put these caps on nice and tight. All right, the system has calmed down, but we still have really low superheat, okay? You look right here, compressor superheat is about 1 degree of compressor superheat. So we have potential of flood back happening here. Really cold suction line. If we look right here, we are flashing. I don't know if the sight glass is going to show it or not because the lighting in there, but the sight glass is flashing. I do have a liquid line port on there, but subcooling is kind of irrelevant on this guy. And I don't know why it's saying 18 degrees subcooling. That's a little odd. I wonder if the discharge and the liquid are mixed up. The discharge line temperature, they're not mixed up, but the discharge line temp is 106 degrees, and that's because we're flooding back on the suction side. So this system needs to calm down essentially. The expansion valves are wide open at the moment, and they're just throwing everything out of balance. What I really want to do is I'm going to do a pump down on the liquid line receiver. The only thing that's really going to calm this guy down is just letting it slowly stabilize out. I think a couple things are going on here. You do have to be careful with the flashing sight glass when you're flooding back, because you can just kind of mess everything up, and it could really artificially make you think that you have a flashing, or that the system's low on refrigerant when it's not really. It's just flooding out the coils right now. So what I can do is, the last time that we worked on this over here, we marked the liquid level in the receiver. So you can see right here that when it was pumped down, the liquid level was up to here. I suspect this system's gonna be low on refrigerant, okay? And we're having those cool mornings, hot days, okay? So yes, it was in a 15-minute defrost when I got here, but 15 minutes wouldn't make the box at 55 degrees. So what I think happened is, I think we're low on refrigerant. So we're gonna check the liquid level and confirm that, and then I'll explain more after we do that. If you look at this stem, you can actually see refrigerant leaking. Okay, that's the oil blowing out. Now, something you can do to slow it down, that's because the packing's loosened, is you can actually tighten the packing once you actuate the valve, and that'll slow down the refrigerant leaks. But anytime these valves are actuated in the mid-seated position or in the front-seated position, they typically will have a slight refrigerant leak out of the packing. If they're in the back-seated position, then they typically don't leak, but sometimes they still do. But so we will go ahead and put the cap back on, and we're letting the system pump down right now. So when I say pump down, what's happening is I closed the king valve, right? I front seated it all the way. The stem went all the way down into the valve, so it shut off the flow coming out. So the only thing, we get pressure out of this port, and the refrigerant flow stops right here. Now, this is the king valve, and the reason why it's the king valve is because I just shut down the entire system. Well, this is my logic as to why it might be called the king valve. I don't know this to be true, but I just shut down the flow of refrigerant and shut down the entire system by actuating this valve. Now, in theory, using that logic, I mean, if you shut down the suction service valve, it would shut down the system too, but that's the only thing that I could think of as to why this would be called a king valve. But anyways, the refrigerant flow has stopped. The compressor continues to pump, and all it's doing is it's taking all the refrigerant from the evaporators, it's pushing it back on the suction line, or pulling it back on the suction line, and then it's getting trapped after it goes through the condenser in the receiver. The receiver doesn't let any more refrigerant go back down into the system. You can see that we're frosting on the valve, on the outlet of the king valve, because it's boiling all the refrigerant out of that valve, okay? So now, if we look right here, we are pumping down. We're at 7 PSI. And I'm trying to see if it's still running. No, it's shut off. So it's already shut off. So what I want to do now is I'm going to take a heat producing device. We're going to heat up the receiver carefully and safely, making sure that we don't overheat any component of it. And we're going to find, once we get it warm enough, the temperature difference. When we find a temperature difference, that's going to be the liquid level inside the receiver. Okay, the liquid refrigerant, when you feel the drastic temperature difference, that's basically going to tell you that that's the separation of vapor and liquid. All right, so if we look at the liquid level on this guy, you can see where the yellow is. You can see where my line is all the way up there. And you can see that it's like the yellow line starts right at about here, right where it says 10. So that's indicating to me that we are low on refrigerant. When I'm charging with probes, I'm going to use a hose that has this, and I open it and let it slowly bleed while I'm putting it on to ensure that we're not getting any non-condensables in that line, okay? So that way we know we've done everything we can, and we can turn it on and just charge refrigerant into it. I actuated the pressure control, got the system to turn on, so it's running now, and I'm just slowly adding refrigerant through the low side. Okay, the compressor is technically still pumped down to speed up the process, and we're just going to keep checking the liquid level, paying attention to everything. Right, now we can clearly see that the yellow is all the way up at this line right here, and it's more of an orange color down below. That's indicating to me that the liquid level is now where it's supposed to be at. So I added a few pounds of gas. Now what I did was I weighed the cylinder down at the van, so when I take it down I'll find out exactly how much I put into it. But that's why it's very beneficial to write down your pumped down liquid level for the next guy, because I came in today and it's slightly flashing. Instead of having to go through all the hassle of trying to figure out what the total flooded charge is, I'll just fill it up to the liquid level, which is where I left it the last time that I put the proper amount of refrigerant into there. So it says that pumped down to here is 10 pounds of gas, okay? But that doesn't mean I put in 10 pounds. I probably put in 4 or 5. Now this system has refrigerant leaks, because refrigerant doesn't just disappear from a system, right? So I'm gonna go ahead and check up here at this pressure control. I'm not getting any signs of a leak. Okay, these are very common to leak, these pressure control in the bellows section, where the capillary tube on the bottom meets the mechanical device that actuates the control. Those things, they always leak, but I'm not seeing leaks on that. So at this point, there's not really gonna be anything leaking up here. I can check the dryer fittings, but I don't see any oil. You would usually see a sign of oil there. I see some nylon from the flare, and that's about it. So I'm not seeing any problems. We need to get downstairs into the evaporator section and do a leak search, but there's nothing I can do about that right now because they're slammed. It's lunchtime. They've got a full kitchen. So we just need to let the box come down to temp, really, and then we'll have to come back on another day and do a leak search. But let's get into why I'm so concerned about the refrigerant charge in the liquid level, and that's because in low ambient conditions, this system has, or should have, something called a head pressure control valve. The head pressure control valve is there to maintain liquid pressure, liquid temperature, basically elevate the head pressure during low ambient conditions, okay? In low ambient conditions, they can have problems, and you actually need to have a good differential between the high side pressure and the low side pressure to allow the proper pressure drop across the expansion valve. And when you have the proper differential across the expansion valve, which is the separation from the high side to the low side, the expansion valve can work properly. If you don't have the proper differential, the pressure difference across the valve doesn't act very well. Now, this is especially true for thermostatically controlled expansion valves, which is what we have on this system, okay? So you need to have that pressure differential for the expansion valve to work properly. Right now, we're in that weird time. This morning, it was about 50 degrees outside, but today it's supposed to get about 95 degrees, okay? So the head pressure control valve, which I'll open it up and we'll verify it actually has one, but the head pressure control valve requires extra refrigerant in low ambient conditions. And I think what happened was this morning it was cold, there wasn't enough refrigerant, the box temp came way high, and the box just could never recover, or they didn't give it enough time to recover. Sometimes in situations like today where we have a hot afternoon, by 1 or 2 o'clock in the afternoon, it's nice and warm, all of a sudden the system will come down to temp because the head pressure control valve stops bypassing, okay? But in the cold mornings, it has a hard time. So that's a dead giveaway on a refrigeration system. If the customer complains that it doesn't work when it's cold outside, but in the afternoon when it warms up, it works great, typically that if it has a head pressure control valve, it's gonna be a low charge situation. So this is our head pressure control valve right here, okay? So basically when it was cold outside, it was trying to bypass and there wasn't enough refrigerant in the system. So I'm gonna put this back on. That condenser fan motor sounds like death too, but that's a problem for another day and we'll bring it up to their attention. So let's finish up on this guy. Still coming down to temp, but it's at about 43 degrees now. We've got all kinds of food in there. There's nothing I can do about that. That's it. The customer actually doesn't even want me to come back and do a leak search, which kind of sucks, but I had to put 3 pounds of gas in it. So I do what they say.
It's a bummer, but this particular customer, towards the later part of the year, they always cut back on spending. And there's a lot of, we go out there, we find the leaks, but then they don't want to fix them. And they just want to wait, and they just want to wait till January, February, March, and then all of a sudden they'll start fixing things. I can only do what I can do, you know, but I still try to do my best to make sure that we are finding the leaks, because I consider that to be part of the initial service call, so that way we have a general idea where the problem is. I still like when I can, you know, I mean, but in this situation, I couldn't get back out, or I couldn't get downstairs to do a proper leak search because they were super busy. It was lunchtime, you know, so I'm at the mercy of what the customers want to do, you know, and I did my best on this one, and that's pretty much it. I really appreciate you guys making it to the end of the video. I highly encourage, if you guys are interested more in those head pressure control valves, to Google Sporlan 90-30-1. You will find a PDF document that'll help you understand charging procedures for those valves. If you don't know the exact refrigerant amount like I did, you can calculate the flooded charge. It's a great place to go to find out more about those valves in general. So I really appreciate you making it to the end as usual. If you haven't already, please consider subscribing to my channel. Check out my website, hvacrvideos.com. If you're interested in purchasing tools, go to truetechtools.com. Use my offer code BIGPICTURE at checkout. You get a discount on majority of the items. It's actually an 8% discount on majority of the items on their website. There's a few things it doesn't apply to, but when you do use that offer code, again, big picture, one word, I get a small commission from that. So it's a great way to help support the channel. You can also support the channel via PayPal, Patreon, YouTube channel memberships. I already mentioned my website, but you know what I didn't say? The easiest way to support the channel is literally just watch the videos from beginning to end. Okay? Again, thank you so very much. I appreciate you, and have a nice weekend. Have a nice holiday. Here in the States, we have the Thanksgiving holiday, so get a couple days off from work, get to enjoy some family time. I hope you and yours have a good holiday season yourself. All right? Again, I really appreciate you, and we will catch you on the next one.